Hello, everyone. It's Mr. Geiselman again. Today we have lecture number 6 on the scientific method, and this is really the scientific method part 1. So lecture number 7 is going to be the scientific method part 2. So that will be your next one. So we're going to go through a few pieces of the scientific method. We're going to put it all together tomorrow. So let's get started. So, what is the scientific method? You guys probably remember from fifth, sixth, seventh, eighth grade that the scientific method is a basic guidelines used by scientists to solve problems. It's a step-by-step process that people all over the place use to come to conclusions and figure out what's going on in their lives. There's a lot of different things you can find on the internet. I'll find a way to get this link out, but there's a link to the video here down at the bottom. If we wanted to use it in a sentence, the scientific method is always going to start with an observation. So we're going to use our senses: sight, sound, taste, smell, touch, and we're also going to use some tools like some technology tools to help us make some observations and then ask some questions based on what we saw. And this is something that I think is really important, is that everybody does use the scientific method all the time. Think about if you woke up in the morning and your phone wasn't where you left it, right? You're going to make that observation. You're going to ask a question. You're going to go through the rest of the steps until you find your cell phone. You don't think about it that way, but it's really what you do. So, the first thing that happens in the scientific method is we make some sort of an observation. We make the observation our cell phone isn't on our nightstand where we left it the night before, right? Or where we usually put it. So our observation is, hey, my cell phone's missing. Where did I put it? That's the next question. Where could it be? Where is it? We're going to try and ask some sort of question based on the observations and the information we have. Then we're going to do some research, right? In the case of your cell phone, you might be looking in places that you last used it. Did you leave it in your bed? Did you leave it in your clothes from the other day? Did you leave it in a jacket pocket? Did you leave it on the couch? You're going to go do some research, all right, and then you're going to come up with what we call a hypothesis. Hypothesis, and this is something that we're going to talk a little bit more about tomorrow. But we're going to come up with our explanation for what happened. I fell asleep on the couch and it fell between the cracks, or I left it in my pants pocket when I went to bed. Something like that. So you're going to come up with an explanation. And then you're going to go test that explanation, right? You're going to test that experiment. I'm going to go check the couch cushions. I'm going to go check the jacket I wore from the day before. And then I'm going to find some results. I didn't find it in the couch cushions. I didn't find it in the jacket. Or I did find it, below underneath my bed. You're going to find some results and you're going to kind of, in our case, you're going to put that into some sort of organized way of showing it, whether it's a data table or a graph or something like that. And you're going to be able to communicate those results. And then finally, you're going to come up with a conclusion. Oh, I thought I had left it on the couch because I had fallen asleep there the night before, but in reality, I knocked it off my nightstand in the middle of the night. That was my conclusion. This is the data I have to support that. So that's kind of the whole process, and it gets a little bit more formal than what I just described, but that's the gist of it, and that's what we're going to talk about today. So observations are just examples of collecting information from the world around us. So we're constantly making observations about the world around us. Right now, you're making an observation that you can hear and see the computer screen or whatever your device you're watching this on. You can hear my voice, right? You're making observations all the time. So there are two types of observations, and I'm not going to talk about them quite yet, but there's two different types of observations we can make. So I'm not going to start the timer. There will be a question that pops up here, but I want you to take 30 seconds and I want you to make as many observations about this picture right here as you can. So take the next 30 seconds, make as many observations as you can about that picture, and report back. So hopefully you made some observations. Maybe you looked at the green tree or the green leaves, excuse me, the brown bark, the red apples. Maybe you counted the apples. Maybe you counted how many branches were on the tree. Those are two examples of different types of observations. And the first one is a qualitative observation. And a qualitative observation is describing the quality of the characteristics. Okay, so we're going to be looking at the apples on the tree. We're going to see, oh, there are 5 apples. Or sorry, excuse me, there are red apples on the tree. There are green leaves. Brown, the bark is brown. All right. If we were at a restaurant, think about all the different things that you can do at a restaurant. You can see the food coming out to other tables. You can hear the waiters and waitresses talking to their customers. You can hear the kitchen. You can smell the food. Hopefully, at the end of this, you get to taste the food. And then, even then, you can touch the food. There's so many different things going on that are qualitative observations. And that's describing the characteristics or the qualities of whatever you're observing. So the example in that one, the apples on the tree were red. Now there's the other type, and that's the quantitative observation. And a quantitative observation is in the form of numbers or quantity. So you can see that there are 16 apples on the tree. There's lots of different things. You can measure things in time, mass and weight, distance, length, size, volume are all different ways you can make quantitative observations. So qualitative and quantitative observations are where we start. Then we ask a question, and a scientific question kind of comes in a format. We're looking at how things interact. So a scientific question is a testable question that scientists want to find an answer to. So for example, it has to be able to compare two things. No, how does the color of the apple affect the taste? How does the number of apples on the tree affect the color of the apples? What is the effect of sunlight on the color of apples? Those are all examples of scientific questions. There are two things that we can test, all right, and we're trying to see how one changes the other. So a scientific question works like that. So let's do a little bit of practice. So if you wanted to see if playing music makes plants grow taller, right? How would you write that as a scientific question? Take a second and do that. All right. If you wanted to see if practicing will improve a player's batting average in baseball or in softball, how would you write that question? How would you write a scientific question with those two statements? Some pretty quick examples. If you want to see if playing music will make a plant grow taller. Scientific question: how does playing music affect plant growth? We're going to see how that music changes how the plant grows. You want to see if practicing will improve a player's batting average. How does practicing is doing something and it's affecting the other. So we're seeing how one, what we call a variable or something that we can change or choose, changes another thing in the experiment. Then we need to do some research. So once you've made an observation, you ask the question about the phenomenon that you see, you need to do some research. Phenomenon is just kind of like the observation that you made. So in your research, your research can tell you a lot about what's going on. It can tell you uh, why practicing makes a batter's average go up, or drills that make a batter's average go up, something like that. And it might make your question and not something you want to test. It may answer it right there. Your research is also going to give you insight on how other people have done that experiment. So what did they use, or how did they observe what you saw? Now, one thing that's really important when you're doing research is that you're going to find past experiments and how they're conducted. But it's really, really important that you find things that are reliable. There's lots of resources out there for you to use. We just need to make sure that they're reliable. Unfortunately, Wikipedia isn't that reliable because anybody can go and edit it. Most of the time, the stuff on there is pretty good, but that's not something you want to really depend on. So things like academic journals and vetted and reviewed texts, like textbooks from companies that have uh, editors and scientists and doctors and people who are in that field. I'm just thinking of a science textbook, but people who are in that field reviewing it and giving their input to what they saw in the book. So right now we're going to skip over the result or skip over hypothesis and variables and things like and really designing the experiment. And we're going to jump to our conclusions in our results sections. The hypothesis and experiment part of this is going to be in our next video. So results are where we're jumping to. We've conducted the experiment. We gathered a bunch of data. Now what do we need to do with it? Well, your results should be organized in a system for displaying the observations that were made during the experiment. A really good way to do this are data tables, graphs, and then explanations, and they all should be part of your results. So you should have some data tables be a part of your experiment. You should be able to visually show the data that you gathered. You should have some graphs that should also do that, and then explanations go along with those. What do the graphs show us? What are we looking at? So the first thing we talked about there was a data table. And what a data table really is just a column and row system used to organize information. We can represent a lot of data in a data table. So we can show which person did the experiment, how many times they did it, their average. We can look at all this data and we can get a lot of information about the experiment that happened. So this example, we have different people running a 100-meter race. We have all of their times right here and their averages. So we can tell a little bit about what was going on in that experiment based on this data table. A bar graph is really useful for us when we're looking to compare several individuals or items. So if we wanted to look, we gather data over months, all right, and this example is buses manufactured. We see that buses manufactured increase as we get closer to the start of the school year. It shows us all the different data for the different months, and it's a really great way to show multiple things and how they interact with one of our variables. A pie graph is really good at looking at something with like a percentage. So the example, we're looking at the favorite type of movie, and each section of the pie or of the pie graph shows us how many people really chose or what data was most prevalent. So in this one, people liked romance movies the most. That's why the chunk of the red pie is the largest. Not a lot of people like drama, and that's why that kind of grayish blue is in the middle. And then there's line graphs, and line graphs are really great for a lot of the stuff we do here in ninth grade physical science, but it's used when we're trying to determine relationships between two variables. We look at velocity and time a lot, or distance and time in Unit 2, but it allows us to estimate the in-between measurements. So we were able to look at populations here on the left between 2017 and 2018. It'll tell us what was going on in between those two data points because we can see the trends on the line graph. On the one on the right, we see that from October to December, gingerbread spices sold a lot more than something like pumpkin spice that peaked in the fall. Then we're jumping to our conclusions. Now we're going to wrap everything up and we're going to create a summary of the procedures, materials, methods, and results, and what it all meant in an analysis of our experiment. The conclusion should tell us if our hypothesis, which we're going to get more into tomorrow, but your hypothesis is what your initial explanation for what happened was, and whether that was supported by the data you found denied or refuted by the data you found, or inconclusive. You can't really tell based on the data that you gathered in the experiment. You can also give us thoughts for new research based on what your experiments accomplished. Finally, then we're going to write these conclusions. So this is part where we're going to have to answer some questions for anybody reading our research. So one of the first things we have to talk about, what question were we trying to answer? Include our independent and dependent variable. Again, those are coming tomorrow. What specifically those are? What was the answer to your question? How does the data support your answer? Does it support it? Does it not support it? All right. What's going on there? And then I want you to think, if your teacher watched every step of your experiment, all right, what are two things that they would say you could do better? What are two things that you think you could have done better within that experiment? What are some things that you knew could have gone better? It doesn't have to be two, it doesn't have to be three, it could be however many that you think could have gone better, or something that you could have changed to make your experiment a little more valid. And then after doing the experiment, what's something you could go further with? What's more research that can be conducted? All right, if you have any questions, like always, reach out to myself, Mr. Oleg, Mr. Swenson, or Mr. Kuhn. Have a great day, everybody.